And our very first speaker here is Jordan Tigani. He is the Chief Product Officer at SingleStore. And today he's going to talk to us about data-intensive applications in financial services. So Jordan tries to keep up with the company's engineering and product teams at SingleStore. He co-created Google BigQuery as a founding engineer. He's co-authored 2 books on the subject and served stints as an engineering director and PM director for that product. In addition, he had a near-perfect track record predicting World Cup soccer matches using machine learning and large-scale analytics. All right, with that, I'm going to go ahead and bring Jordan up to our virtual stage. Hello, Jordan. Welcome to the conference.
Hi, thanks so much, Kate. I do want to just say that as a word of warning, I'm maybe getting a migraine, and so I may be rendered unable to speak at one point. Hopefully, if that happens, Kate can just turn back on the music, and you don't blame her. But I also might have to close my eyes. But anyway, on with the show, as they say.
Jordan, we're here for you. If you need anything, let us know. We're happy to take over at any point, and we've got Tiffany backstage as well if we need to kind of let her go first, and if you wanted to go after. But I'll let you go ahead and take it away. I'll hop off the stage. Just let me know if you need anything.
Sure, no problem. Thank you. I appreciate that. So the saying "time is money" is an old one, and I think no industry gets that as much as financial services. And in fact, they really quantify it. And a good way to see this is if you're familiar with the book Flash Boys by Michael Lewis, he talks about spread networks, and they built a fiber optic path from New Jersey to Chicago in order to save just 4 milliseconds in the round trip time to get from their data center in New Jersey to the Chicago Mercantile Exchange. It cost them $300 million to do so. And the reason that they did that, the reason that made sense, is because the value of that time and the value of that data was so high, and in particular being able to make decisions based on that data. So financial applications have data problems, and those data problems aren't just limited to high frequency trading, algorithmic trading, but things like providing rich personalized customer experiences. And if you want to provide a rich customer experience and provide recommendations, you need to be able to provide those recommendations based on data that's happening right now, and based on real world data, and you need to be able to do so quickly. If you want to be able to detect fraud in the middle of a transaction, that requires a lot of understanding of the data about what else is going on. It's got to be up to date, and it's got to be fast. So there's a term for this type of application where data is the real sticking point, and that term is wasn't created by me, but I think is a great way of describing what the problems are, and that's a data intensive application. Martin Kleppman, in his great book, he describes that a data intensive application is one where the primary challenge is data, and in particular, the bottlenecks are either the complexity of data, the size of the data, or how fast the data is changing. And I think one thing that you'll find is that most of the interesting applications of the age really are data intensive. If we look beyond financial services, a variety of people that are changing their markets are really data intensive applications at their core. It's not just something that's sort of built on, but is really the core of what these applications do, and it's the core of what makes them able to provide a new and improved type of experience. So what is it about data intensive applications that they need? What do they need from their data infrastructure? And I think of it as really 2 things. Fast ingest, low latency, high concurrency. You need fast ingest because you need to be able to react to the latest data. If you're looking at yesterday's data, or if you're looking at data that's delay of 15 minutes, or even 15 seconds is too much. You need low latency because the Google and Amazon have shown that every 100 milliseconds that it takes, some users are going to lose attention, and then in fraud detection, for example, like you need to be able to understand whether or not something is fraud, and often the SLA is single digit milliseconds. You also need high concurrency because you can't always know or control what's going to happen at a particular time. If there's a major market event is going on, for example, that's going to be the case where access to data is most important and the most number of interesting things are going to happen. So you put these things together, and you get something really, really important. But one of the problems that I think people find is that the traditional solutions for analyzing and understanding data, or providing the data infrastructure for data intensive applications, it doesn't really work. And so if you look at transactional databases generally are not great at the context, at understanding what's going on sort of outside of pure kind of transactional performance. As you scale, and you want to look at what's going on in the rest of the market, you want to do real-time recommendations, etc. You often have a really difficult time. On the other hand, data warehouses are great for analytics, but they're really not great for kind of online access to data. If you think about the fraud detection case, or the anything real time, or we have lots of users, a data warehouse is really not the right application to use. So single store is a fast database for that's really designed for data intensive applications, and there's a reason for it, and the reason for it is the architecture. It was designed as an in-memory database that with incredibly low latency, and then a few years ago we added the ability to add an analytical storage engine that provide a durable storage engine. So it kind of has both sides of the coin, the incredibly low latency transactions and the ability to do large scale analytics. Analytics at the trillions of rows per second. So you don't have to just take my word for it. We have customers that are experiencing these types of performance goals. Many of these customers don't like to be kind of known by name, but if you look at some of the things that they're doing. So a large content provider is doing 12 million updates per second. So being able to do incredibly fast updates, not just to that's really hard to do. A tier one bank is doing fraud detection on the swipe. Their SLA, their hard SLA, they can't do fraud detection if they can't detect fraud in under 50 milliseconds. Single store is running actually several queries within that 50 millisecond goal. And a large ride sharing app runs 40,000 users per second and a 2 millisecond SLA. So they have a 2 millisecond SLA to do user segmentation. So that's just the kind of thing that you really can't do with most databases. And to talk a little bit about, okay, let's say you're building a simple financial reporting app. Let's say Yahoo Finance, circa 2005. If you're building that kind of application, you can kind of use any database. It's whether you're using Mongo, MySQL, SQL Server, etc. Lots and lots of different databases can work. But if you're building a modern financial app, something that you want to do some sort of richer data, you really need a different type of database. If you're building a reporting app that you want to know, just not just sort of what a particular what Google stock is doing today, or even has done in the last couple of months, but you want to know what's going on today, what's being undervalued, what's being then being able to build an API. To go back to actually the Flash Boys book, they built a new exchange for kind of leveling the playing field for high frequency trading, and their reporting arm is IEX Cloud, that's using single store to build rich reporting over over financial data. So if you have one takeaway from this talk, I'd like people to understand the value and the power of data intensive of applications. If you have two takeaways from the talk, the other one I'd like you to get is just that single store is a great way to do data intensive applications, and in particular for financial services. And with that, thank you very much.